All right, so we're going to go over the next step, which is a mass to mass conversion. And so we just add one more part when we do this. So let's look at our chemical equation so we can balance one. Okay, so we have a series of reactions that inflates airbags and automobiles. It has a decomposition of sodium NASDAD or NaN3 to produce nitrogen gas and solid sodium. So we need to determine the mass of nitrogen gas that is produced when you see 140 grams of NaN3 decompose. So let's write our balanced chemical equation. So we have NaN3 decomposes to produce nitrogen gas and sodium. So we need to balance that chemical equation. So 2, so we can get, we want 6 nitrogen. Remember, you can always make a odd number even. We can never make an even number odd. Okay, so now that we're balanced, let's start with what we have is 140 grams. So 140 grams of NaN3. Okay, we have to get it to moles because we can do a mole to mole ratio that we learned in section 1, but we can't just go grams to moles. So we have to look at our molar mass. So the molar mass has to go here. So this is a 65 grams of NaN3, which equals 1 mole. Then we can do our mole to mole conversion. So we have 2 moles. From the balanced chemical equation, we get our molar ratio here, and we need to go to nitrogen, so that's 3 moles of N2. Again, this step is our mole ratio, and the molar ratio always comes from the balanced chemical equation. Once we have that, now we're at nitrogen, so now we can convert that into grams by putting our molar mass. So that's 1 mole of nitrogen gas over 28 grams, because remember it's grams per mole, of N2. Multiply the top, divide it by the bottom, and you get 90.46 grams of nitrogen gas. So remember, we have to start with what we're given, convert that into moles. Then by using our molar ratio, we can convert into grams of the other substance. Sadie, come here. So let's do another problem. So we have a fuel of methanol is made by a reaction of carbon monoxide and hydrogen. So we have CO plus H2 produces CH3OH. Now we have to make a balanced chemical equation, so the only thing we need to do is put a 2 there. Now we're balanced. So we were started with 45 grams, so that's what we start with, of our CH3OH. Remember, we have to go to our molar mass of that, so 32 grams over 1 mole of our CH3OH. The next step is our molar ratio. This comes from the balanced chemical equation. When we look up here, we only have 1 mole of our CH3OH, and we have 2 moles of hydrogen. Then we go to our mass, so that's by using our molar mass, so 1 mole of H2 over 2 grams H2. Go through, and we get 5.6 grams of H2. Now remember, labels cancel as we go. So what you see is a diagonal relationship. Labels are the same. Labels are the same. Labels are the same. This is what you have in your answer. All right, one more problem here. So let's mix it up a little bit. It's going to give us moles. We got to go to grams. So we have potassium chromate, lead nitrate. It produces lead chromate, potassium nitrate. So let's do a balanced chemical equation. Remember, these are all ionic compounds. So I need a polyatomic chart out. We should have C2KRO4 plus PbNO32 produces Pb, lead chromate, CrO4, plus K2NO3. To balance it, just need a 2 here. So let's start with the moles of what we're given. 0.25 moles of potassium chromate. Because we're already in moles, we don't have to go to grams. We can actually simply go to our molar ratios. That's what we're going to go to. So we look up the balanced chemical equation. We have 1 mole of potassium chromate. So that's our given, K2CrO4. Oh, that's bad handwriting. Sorry about that. And then we are going to go to lead chromate. So that would be our 1 mole. Again, this is our molar ratio from the balanced chemical equation of PbCrO4. So now that we have that, all we have to do now is go to grams. So we know 1 mole, because it's grams per mole for molar mass, of PbCrO4 is equal to 323 grams of PbCrO4. We solve for that. You get 80.75 grams of lead chromate. And so that's how we solve for those. It should be an 80. And so then that's how we solve for those. So not too bad. Just remember we have this diagonal relationship always here so that we can cross off labels. All right. Have a good day.